Okay, well, I think we will go ahead and get started. Thank you for joining us tonight for our monthly webinar series, Ask a Physicist, that takes place on the last Monday of the month. Next month's seminar will be on November 30th, where our physicists will be discussing how many universes are there. Don't forget to register for that webinar at our website at beyond.asu.edu. So tonight's physicist will be discussing is ET lurking in our cosmic backyard. First, we will hear from Paul Davies and then from Sara Walker. If you want further reading into what is lurking into our cosmic backyard, Paul Davies has a book on SETI called The Eerie Silence, which dives further into tonight's topic. You're welcome to submit your questions in the chat option or the Q&A section at the bottom of your screen. Without further ado, I'm going to turn it over to tonight's moderator, Maulik Parikh, who is a theoretical physicist that works on quantum gravity here at the Beyond Center at ASU. Maulik?
Thank you, Katie. And welcome everybody to today's Ask a Physicist webinar series. This is the third of our series so far. And today we're going to ask whether there are aliens lurking in our cosmic backyard. Are they already here? Why haven't we seen them? And what could they look like? What would we say if we met them? Should we be scared? So we have two experts today, and I'm just the moderator, so I'll be taking questions. It's an interactive format. So we'll have two short presentations, one from Paul Davies, and then followed by one from Sara Walker, after which we'll open it up to everybody, and you can just ask your questions in the chat, and I'll select some of those and forward them on to our experts. And so without further ado, here is Paul Davies. Let me briefly introduce them. Paul Davies is the director of the Beyond Center at Arizona State University. He's a theoretical physicist. I know him for his legendary book on quantum field theory in curved space-time, but he works on basically everything, and he's especially a fan of crazy ideas. And one of those is whether there are aliens not only in our cosmic backyard, but perhaps even here on Earth. And our other speaker today is Dr. Sara Walker. She's a deputy director of the Beyond Center, and she is an expert on astrobiology. So that's perfectly suited for today's topic. So without further ado, here is Paul Davies.
Thank you, Maulik. I have to say that you look a little bit like an alien yourself.
Yeah, I'm flitting in and out because I wore a green polo on the green screen.
It's the fancy technology that you have chosen to see. Anyway, ladies and gentlemen, welcome to another of our Ask a Physicist series. I hope you'll stay with this series as we progress into our pandemic future. Now, whether or not we're alone in the universe is one of the oldest and deepest questions that human beings have asked. And for most of human history, it lay almost entirely in the province of religion and philosophy. But in the last few decades, it's become part of science too. And the subject of SETI, that Katie briefly referred to, is the search for extraterrestrial intelligence. And it began about 70 years ago, when a small group of gung-ho radio astronomers decided to start sweeping the skies with radio telescopes in the hope of stumbling across a message from ET. Well, all these years on, what have they found? How are they getting on? The answer is, I'm afraid, nothing but an eerie silence. If ET is out there, we have yet to receive any definitive evidence. Now, Radio SETI, which has been the mainstay of the search for extraterrestrial intelligence, as opposed to just life, but intelligent life, suffers from a fundamental flaw, and that is the following. The radio waves travel at the speed of light, and we have to ask if there is a civilization, say 1,000 light years away over there, why would they be beaming messages at us? They will see Earth as it was 1,000 years ago. There were no radio telescopes on Earth 1,000 years ago. They may know that there is intelligent life on Earth. They may see the pyramids of Egypt or Great Wall of China or signs of agriculture, and they may deduce that any millennium soon we would have radio technology. But it would make no sense for them to beam messages at us until they knew we were on the air. We don't have the capability of picking up domestic radio traffic anywhere outside of our solar system. So we wouldn't hear their normal radio traffic. They'd have to deliberately beam messages at us. And it seems like the only reason they would do that is if they were sure we had that radio technology. Now our radio waves from the first feeble transmissions have gone about 100 little more light years out into space. And in astronomical terms, that's really not very far. And the chances of there being an extraterrestrial civilization within that volume of space are probably pretty low. So I don't think we can expect to be receiving a message from ET anytime soon. Does that mean we give up? Well, no, because the question, are we alone in the universe, doesn't require us to receive a message. We don't need to have ET saying, you are not alone, I am here too. It's merely necessary for us to detect incontrovertible signs of non-human technology. We detect technology all around us. Is there any non-human technology? That would settle the matter. So is there anything out there in space that could not have a natural origin? And these days, we tend to use the term techno-signatures for such a thing. So it's become a sort of gone from being a totally crazy topic. I might say that when I got interested in this subject in a previous millennium myself, when I was a student, one might have well professed an interest in looking for fairies. It was considered self-evidently absurd to believe that there would be any extraterrestrial life, let alone intelligent life. But the pendulum has swung, and so now we can talk about techno-signatures without blushing, at least among our colleagues. So that's what I'm talking about here, the search for signatures. That would be a techno-signature if you saw that. It's actually a photoshopped image, you won't be surprised to know. But if we saw that, on the moon or one of neighboring planets, we would certainly sit up and take notice. So something like that. That's an unambiguous techno-signature. It's actually a rather deep philosophical problem as to what it is, other than human judgment, that gives the game away. Could we program a computer, for example, to search for generic techno-signatures? What is it in that word techno that can be translated into objective facts about the world? I'm not going to get into that because it's a very deep problem. The first attempt, no, it wasn't the first attempt. People thought about techno-signatures a long time ago, hundreds of years ago, but the first in the modern era to suggest such a thing was Freeman Dyson, who sadly died recently, famous physicist, futurist, and speculator. He said that a very advanced civilization might be so energy hungry, it would entomb its host star in a sort of shell that might gather all of the radiation that emanated from it. So this would be like a solar energy project with a vengeance. Now, obviously, humanity is not able to pull the solar system to bits and build such a thing, but who knows, after 10 million, 50 million years, a civilization might do that. You could go looking for these Dyson spheres, and astronomers have. They haven't found any, otherwise I'd be giving a very different lecture. But that's the type of thing. That would be a techno-signature. We wouldn't know anything about this civilization, but we could answer the question, are we alone? The answer would be no, we're not alone. But what about closer to home? Could there be any techno-signatures within our solar system? Now, a very important point I want to get across here. The solar system is a little over 4.5 billion years old, so that's about a third of the age of the universe. There were stars and planets around long before Earth even existed. If the universe is teeming with life, and if there is a lot of intelligent life out there, and I'm yet to be persuaded, but if that is the case, then our solar system could have been visited by aliens any time in the last 4.5 billion years. They don't have to come right now. They could have come at any time. And so the question is, if we pluck a number out of midair, say 100 million years, supposing there had been alien technology in the solar system 100 million years ago, would we know that? What would the traces be? Are there any techno-signatures that would survive 100 million years that we might still find. And notice I say alien technology in the solar system. We don't have to have flesh and blood aliens visiting in their spacecraft, as in the traditional science fiction stories. It merely needs to be some sort of non-human technology in the solar system, sometime on an immense timescale. That's what we should be looking for. Now, when I wrote The Eerie Silence, I thought, well, what does last for 100 million years? And the answer is not very much. But there are some things. Buried nuclear waste, for example, can remain radioactive for billions of years. If there's large-scale mining or quarrying, that this, even though they get buried, even here on Earth, that is in principle detectable gravimetrically. Biotechnology offers some possibilities. I'm going to come back to that at the end. And then, of course, we could look for artifacts like the famous obelisk in the Arthur C. Clarke story 2001. So these are all things we might look for, but they all have their challenges. So, for example, if there were any large-scale mining or quarrying, if we saw an asteroid, asteroids are great things to mine, by the way. They have lots of very valuable minerals. If ET had been doing that, we might, even after a long period of time, see examples of modification. Some years ago, I just embarked on some crazy project. I blamed the student. I was teaching a class on SETI, and the student said he had an idea because he was part of the Lunar Reconnaissance Orbiter project, which is taking place at Arizona State University. The moon's being mapped to half-meter resolution by this satellite, and the pictures are free on the internet. So any of you who get fired up by what I'm saying now, go look at those pictures, see if you can spot technology on the moon. And the answer is yes, you can. There are certainly techno-signatures on the moon showing up in those photos. Unfortunately, so far, they are all human technology, but it's a proof of principle. And because the moon is relatively inert, even a chunk of alien technology plonked there 100 million years ago might still be detectable today. So that's one particular avenue. The media got hold of this and they said, you know, Davies is suggesting that aliens are on the moon or something. I'm not suggesting that at all. I'm saying that that is exactly the sort of thing we should look for. The chances of success are, of course, exceedingly remote. But as Frank Drake, who started SETI, once remarked, if you don't look, the chances of success are precisely zero. I just want to finish up by mentioning a new idea that's due to my friend James Benford. He's pointed out that as the sun goes around the galaxy, from time to time, it brushes close to other stars. I had no idea there were quite so many that came fairly close to our solar system, but they do. And if any of these stars had planets with civilizations on them, close passage would provide a good opportunity to send a probe to the solar system. And I'm talking now not over billions of years, but over thousands or tens of thousands of years. In fact, Schultz's star came very close, only 70,000 years ago. Might there be some Schultzians who decided to send a probe to the solar system? Well, we could certainly still detect that if we knew where to look. So where do we look, as a matter of fact? Well, Jim has the idea that there are objects very close to Earth. I've talked about the moon, and you might think, well, that's the closest that we could get other than Earth. But there are actually bodies that are somewhat closer. They're not very big. They typically the size of a football field, something like that. But they're co-orbital. They're not orbiting the Earth, but they're following the Earth, trailing it as it goes around the sun. So these objects can come really rather close, not quite as close as the moon, but almost. We could send probes there for very little cost. And if you wanted to observe the Earth, if you wanted to put a, some sort of probe on an object to just remain dormant until such time as it chooses to make contact, then one of these co-orbital objects would be great to go. And so he calls these lurkers, these bits of technology that might be lurking, waiting for their chance to wake up and say hello to us. And one in particular commends itself, 2016-HO3. I don't know what it stands for, but anyway, HO3. And China is in fact planning to send a probe to that particular object. I want to finish with this is literally the last slide. I mentioned biotechnology. Is it possible that if in the distant past, and it could be very distant past, life's been on Earth 3.5 billion years, a long time ago, if aliens have been here and done stuff in the biosphere, maybe created their own organisms or something, that could show up in the biological record. From genetic sequencing, we could tell that something amazing and dramatic happened if we found like a side branch on the tree of life, or a totally separate tree, which we might call a shadow biosphere. This could be deliberate, or it could be inadvertent. It could be that ET came visiting, tramped around on our planet, and microorganisms from this world could have escaped and formed a shadow biosphere that could be all around us on Earth right now. This is my craziest idea, but it would be a case of, I'll leave you with this thought, of one small step for ET, one giant leap for Earth's biosphere. And at that point, I will stop and hand over to Sara.
Great. Thanks, Paul. I need to be enabled screen sharing, actually.
Well, I've stopped mine.
I know. I think Katie has to just give me permission as a co-host. I'm not sure I disagreed with any of those points, so it's going to be a little tricky to actually disagree with you.
You're good to go, Sara.
Thank you so much. Yeah. So I'm going to be presenting sort of the counter argument to Paul this evening, which is why ET is not lurking in our backyard. So why we should not expect to find any alien life right next door or in our solar system, even evidence of it, as Paul had argued, that might be 100 million years old or so, because the odds are so low. So the first piece I wanted to kind of contribute to the discussion is that we have kind of this idea in our mind from science fiction about what aliens are like. And the truth of the matter is there's probably nothing really like the Galactic Senate out there in the galaxy that, is a unified federation of alien technologies, and they're all ready to go out and explore the galaxy and discover new life and make friends. That's obviously something that has emerged from human imagination, and one of the questions that we might ask is, how close is anything that we can possibly imagine to alien technology actually accurate? And there's been a lot of explanations for maybe why we haven't observed really intelligent aliens coming to visit us yet. So part of the paradox here is something called the Fermi paradox, which is if there is such a federation, or life is common and technology is common and intelligence is common, where is everybody? As famously stated by Enrico Fermi over a lunch conversation. And we don't know the resolution to this paradox, why we haven't observed anyone, but some of them are, maybe there is such a galactic federation and we're too primitive to actually have them come visit us yet. Or maybe there are other issues that, civilizations just don't live that long and they can't get to the phase of that advanced technology, which becomes an existential question for us. But the truth of the matter is we don't know. And we don't have any expectation to expect alien technology to be anything that we can anticipate. But the real hard problem is not just that we don't know what we're looking for, what kinds of aliens might be out there, or that it might be, not things within the realm of our imagination to really think about alien technology, is that we just don't even know if there's any intelligent life out there. Some of us might argue we don't even know if there's any intelligent life on Earth, especially nowadays. But assuming that there might be some intelligent life out there, how can we actually think about it? Well, probably one of the most famous ways that people have tried to really talk concretely about this is something called the Drake equation, which is nice because it really talks about trying to read how we can reason about the problem. And so I'm not going to really go through all the details of the equation. It might look fairly complicated. But the main idea behind the Drake equation is to try to predict how many civilizations are out there in our galaxy, for example, that we might actually be able to detect their technology based on understanding star formation rates, planet formation rates, the number of planets we might expect to be sort of habitable or capable of supporting life. And then also the likelihood of the origin of life, evolving intelligence, and then the longevity of those intelligent civilizations. So the terms get a little bit more uncertain when we go from thinking about rate of star formation to how long an intelligent civilization is actually going to be around and releasing detectable signs into space. And so most of these terms on the life side, these F sub L, the probability of life, the probability of intelligence, the probability of technology, and the lifetime are completely unknown. We don't really have any way of constraining these accurately. And part of the reason is because we have only one example of a planet that's ever been inhabited, which is our own. And that basically means that we don't have any possibility of constraining these likelihoods. So talking about the possibility of alien technologies visiting us is actually very premature when we don't even know the possibilities of the prior steps, particularly the origins of life. We don't know how often life emerges in the universe, and we don't know once it emerges how frequently we get technology. Nonetheless, you will hear many people argue that even if the odds are very low, there's so many chances for life to emerge in the universe because the universe is so big that we should expect some life to be out there. So we tend to be an optimistic species. We like to think we're not alone in the universe, and therefore, wouldn't it be a nice, friendly universe if there were some other people out there or things for us to talk to eventually in the far future. But the universe is obviously very big. So this is an image of the Hubble Deep Field. So each one of the points of light in this image is a galaxy. This image is about the size of your pen point. If you look at the night sky and you want to look at like a little dot in the sky, that's about how big this image is. It has about 10,000 galaxies in it, each of them having billions of stars. And so you might want to argue with all of those chances, maybe life could be out there, even if the probability of the origin of life or evolving intelligence like us is super small. But you still have to require that civilization, once it appears, actually has a long enough lifetime that you can observe it. And furthermore, this is also not dealing with the issue that we have to be in communicating distance. So these are all galaxies that are very far away. We might look closer by at our nearby neighborhood of stars. So Paul had showed an image of, our neighborhood about 100 light years or so out. We do have a few stars nearby, but if the probability of getting, the chances of getting life on a planet are so small that it might be 1 in 100 billion stars or 200 billion stars actually has life forming on that planet, then there's no chances that there's going to be something in our local neighborhood. And actually, even in the timescales that Paul was arguing about of taking, hundreds of millions or possibly even billions of years that they've been around to get to us, that they might even be able to do that. Now, there are some speculation that maybe this has happened already. So faking extraterrestrial intelligence, we have had visitors from other stars, so we know it's possible to do interstellar travel. There was a famous object that entered our solar system in 2017, breezing through the solar system, and people were in uproar that this Amawa might actually be an alien spaceship, and it was actually proposed it was because it had a cigar shape and was traveling about 57,000 miles per hour. It could fit the bill. It had a trajectory that looks like it was coming from another star system. But it's also very consistent with our models of, people are starting to try to prove models of what could explain it abiotically, more likely than it being alien intelligences in a spacecraft entering our solar system. It was just a rock. A little disappointing, not quite as exciting, but probably the more likely explanation. And all of this assumes that extraterrestrial intelligence is A, recognizable, B, common enough in the universe to actually, encounter us. And then the final one is that it's even interested in being encountered or has any kind of norms of, the desires that we have to expand out in the universe or to explore or to make contact. Those are very human traits, and perhaps it's the case that other intelligences out there might either be so different than ours that they're unrecognizable, or even if we could recognize them, they don't really care about being discovered, and perhaps they never actually expand beyond their host planet. And in Paul's book, The Eerie Silence, he mentioned he even proposes a scenario where they become quantum computers in the long-term post-biological future, and they really just need a cold, quiet place to live their existence out in some computer software program. They don't even need a planet anymore. So why would we be making contact with the most advanced intelligences? So they're probably not like us. I just wanted to talk a little bit about sort of a more recent discovery, just to conclude, which is this idea that perhaps there might be life lurking in the clouds of Venus. And this kind of life would be microbial life that might have some metabolism like organisms on Earth and produce a byproduct molecule called phosphine, which was proposed to be a biosignature gas. So we've been talking mostly about technosignatures, which are signs of alien technology. Biosignatures are signs of alien metabolism. And phosphine is kind of a special molecule because it's believed to maybe only be produced by biology under certain circumstances. But even this has been a subject of contentious debate in the fact that there are many known mechanisms for producing this small molecule without life. It's even made in the clouds of the planet Jupiter. So it seems likely that maybe it could be made in the clouds of Venus. And exhausting all of the possibilities of non-living systems to make this molecule is actually nearly impossible because it's limited only by our imagination and the amount of observational data that we have from Venus. And proving that it's actually biologically produced is even harder. Which is sort of similar to the idea that Paul was talking about alien technology. It seems obvious that we should recognize it when we see it, but it's not actually obvious that we're going to recognize signs of alien life. And in fact, in the case of phosphine, it's now debated whether we made a detection at all, because there's been some increased evidence that maybe we didn't even detect the gas to begin with. So there's a lot of debate around objects in our solar system as far as whether they've been produced by life or not. Because the problem is so hard. So even if we did have aliens lurking in our backyard, we might not ever know it because we don't know what we're looking for. So thanks. I'm going to conclude on that.
Okay, thank you both for those presentations. And now I'd like to invite questions. If you have any from the audience, if you have any questions, please enter them into the chat. I'll start with two questions that both pertain to the Drake equation. They're related questions from Daniel Simmons and also from Scott Riley. And basically they say, well, they wanted you to estimate, given the Drake equation, whether you think that it is reasonable to assume that, that we are alone in the universe or not. And in fact, and Daniel Simmons specifically quotes you, Paul, in your 2010 book, The Eerie Universe, where you said, we are probably the only intelligent being in the observable universe. Do you still believe that?
Yes. Drives me crazy when people use this word belief. Because, we're scientists, so we work with the evidence and probabilities. And so I don't remember actually writing anything quite so extreme. But my point of view, which Sara has articulated, is that the big unknown is how you go from non-life to life. We don't know what that number is. Is it inevitable given the right mix of stuff, or is it a near miracle that's happened only a few times in the whole universe? It's true, the universe is big. There are a lot of sites, but it's not that big, 10 to the 23 planets, and you get probabilities much smaller than that when you start shuffling molecules. So we don't know what that is, so it's impossible to answer. I really hope we're not alone, but I don't think we, on the basis of what we know about the emergence of life, let alone the other factors in the Drake equation, we can possibly put a number to it. So we should just go look.
Okay. And here's another question. This one is from Barbara. How do astrobiologists know what to look for?
I'll let Sara take that one because she's an official astrobiologist who just received a lot of money from NASA to go look for something. So how do you decide?
I I was going to say we don't really know what we're looking for, but that's probably not the party line I should be toting. I think this is actually probably the hardest question you can ask about looking for alien life, and it boils down to the question that there's two couple questions. We don't know what life is. And therefore we don't know what its universal signatures are going to be. And this is related to the problem, the origin of life, and why we haven't solved it yet, at least from my perspective. But the way that astrobiologists have traditionally thought about looking for life is to look for molecules that we know that life uses on Earth. So this might be in the solar system, looking for things like amino acids, which are components of proteins in all life on Earth, or looking for DNA. If we're looking on exoplanets, we look for things like oxygen, which is a byproduct of the activity of life on Earth, or methane is another gas produced by life on Earth, which is one of the reasons that phosphine also became a candidate, because it might be another gas that could be produced by life on Earth. So all of these things are very focused on the chemistry of life as we know it. And so far, we don't really have a lot of systematic ways of approaching the question of how do we look for life as we don't know it. And that's really the challenge that we need to confront as astrobiologists, because we don't know if we're common or rare examples of life in the universe. So we don't know, as Paul and I were debating, whether life itself is common or rare, but even within all of the living systems that could exist in the universe, we don't know if we're a typical one or an atypical one. And so we kind of need new thinking to guide our search. And I think there's a lot of ideas approaching that. And one of the things that I spent a lot of time thinking about is what are the universal properties that characterize living systems on Earth and on other planets that might not be specific to the chemistry. And there's a lot of ways of asking that question, which could fill a whole nother hour. But that's the traditional versus other ideas. Go ahead, Paul.
Just make a couple of comments. One is that, Sarah, you've been talking about the jargon word is biosignatures.
Yes.
And we've tried to focus in this discussion on technosignatures. So we're going one further to intelligent life and technology. But we can disconnect even more, because it's my view that sufficiently advanced intelligence would not be biological anyway. It would be post-biological. And even on Earth, we're outsourcing the intellectual heavy lifting to computer systems, machines, robots. We lack an appropriate term. In another 500 years, the human input into the big intellectual exercises on planet Earth is probably going to be rather small. So if we do end up encountering intelligence beyond Earth, we might well not be dealing with biosystems at all. That is exciting, but it also makes it harder, because in principle, as you mentioned, a very advanced quantum computer, quintelligence, as Frank Wilczek calls it, might not even be on a planet, it might not even be in a galaxy. So it widens the volume of space that we have to search, but it makes it that much harder to know exactly what to look
for. Thank you. I have a question here from Dale Zhang, who asks a question that I think has also been raised by Elon Musk and others, that is it wise to search and try to contact the aliens? Would they, if there were intelligent aliens, would they likely to be benevolent? Certainly when we have visited Australia, we have decimated the native species, and perhaps a more advanced civilization might do the same to us. So is it a good idea to attempt to contact alien civilizations?
I have a strong feeling on this, but Sarah, do you want to have a go at that?
I got the last one first, so why don't you go ahead?
Because this is a question that really drives me crazy. And there's some very distinguished people who said, oh, it's dangerous to do this. Stephen Hawking, I remember, went through a phase of saying that, in spite of the fact he came to ASU and we sent a signal into space. but never mind. So I think it's totally ridiculous, because you have to ask, why would advanced civilization be interested in planet Earth? There are two reasons. One is they're interested in the planet. The other is that they're interested in life on the planet. The planet's been here for 4.5 billion years. If they wanted our planet, they could have come at any stage. They don't need us to invite them in to say we're here and it's wonderful. If they have the technology able to come here, they would have the technology able to discern that this is a wonderful planet. Actually, I don't think it is wonderful. I think if you're an alien life form, the last thing you want is a planet that's already got a different form of life ensconced on it. You want to pick one that's uninhabited by any form of life. But if they wanted the planet, they wanted it for minerals or something, they could have come and taken it. It's inconceivable that they would want to come here for us, that they would say, oh good, there's an intelligent life form over there, we can go over and wipe them out. I mean, that would make no sense at all. And given the vast resources necessary for interstellar travel, you'd have to have a very, very good reason to go. So I see no problem whatever in sending signals into space, apart from the fact that, you know, it's a bit of fun, but the fact that it does raise the question, who speaks for Earth? And naturally, I think it's me. But other people are going to think, well, you know, we should be very careful about what we say about ourselves. And that is a legitimate reason. But I think there is no problem about advertising our presence. And as a matter of fact, what we're saying now is going to go out into space at the speed of light. We can't get those signals back. So these words of wisdom in 100 years will be received 100 light years away. And they'll say, yeah, Davies had it right.
Well, they might not wipe us out, but you're not worried that they might want us as exotic pets?
Or come to eat us, as some people say. No, I really am absolutely not worried. Of all the things to worry about, that is pretty low down on my list.
Yeah, same for me. I was thinking it would actually be a good thing if they wanted us for pets, because that's like kind of a nice, like pets usually have a good lifestyle. But I just wanted to add to that, just the fact that we have a tendency to put like human values on the way we think about aliens. So Paul made the important point that we have to think about who speaks for Earth, which is about our values as a civilization, you know, like all humans. How do we speak for ourselves, and how do we have like a unified vision of what we are? And that question is actually hard enough of itself, but then to try to impose on alien intelligence that it has at all the motivations that we have, or the desires we have, or would behave like we do, is, I think, a huge stretch, just for the same reasons that it's a huge stretch to assume that they're going to have the same chemistry at their basic. We just don't know enough to say what's universal about life or intelligence on Earth that's going to exist in aliens. So I think it's a premature concern also for that reason. Okay,
here's a question from Thomas Hullon. This is again about the gas in Venus's atmosphere. I know, Sara, that you've expressed skepticism that this gas has a biological origin, but if it did, what might that life look like?
Yeah, so it's not necessarily that I'm well, what I'm skeptical of is there's not sufficient evidence in place to actually make any claims about it being biological in origin. So I have I think that we just need stricter standards when we make announcements about detection of alien life, and that we weren't very strict in this particular announcement. But it doesn't mean that it couldn't be what's called a biohint. So there is this idea that maybe some of the things that we might want to think are biosignatures, true signs of life, are really not actually definitive and could be hints of the kind of biology there. Now, when we're trying to model something like phosphine on Venus, though, we do make assumptions that the life is like life on Earth. And so we're using models of the chemistry of life on Earth. But how it's been thought about for this particular case is there might be some microbial ecosystem in the clouds of Venus that can somehow stay aloft for millions of years, and is producing this gas at a particular layer in the Venusian atmosphere that has a temperature that's conducive to life as we know it. And so that's sort of the running set of theories or ideas about what life on Venus would be like.
Could I just chip in here? Yeah, because it's pretty clear that over the history of the solar system, lots of rocks from Earth will have gone to Venus, because Earth gets hit by comets and asteroids, and the rocks get splattered all around, and they'll go to Mars and they go to Venus. Conversely, there are a lot of Mars rocks on Earth. ASU has a collection of them. If anyone's interested, you have to ask permission to go see them. But we know Mars rocks come here. Nobody's yet found a Venusian rock, but I'm sure they exist. It's harder to go from Venus to Earth than it is from Mars to Earth. But it will have happened. And so Earth rocks, which are teeming with microbes, we know they're not just inert lumps, they've absolutely chock full of microorganisms, will have gone to Venus. So if Venus had a cloudy ecosystem that could sustain life, then Earth life plunging through it would make a home there. So now we divide into two. When people say, well, do you think this is good evidence for life on Venus? It's entirely bimodal, because on the one hand, if you think that life has got there from Earth, then this is really quite good evidence. You have to apply Bayes' rule. You have to think of what is your prior probability for this to happen. The prior probability for Earth life spreading to Venus is close to 1, in my view. And so therefore, any little bit of evidence, any bio hint, is going to support that. But if you're talking about life originating from scratch on Venus, then the probability of that is, in my view, extremely low, in which case this biohint doesn't help at all. So it really depends which scenario you're talking about. What we would all like, that is we astrobiologists would all like, is a second genesis. We want to know, does life pop up all over the universe, or is it a bizarre freak accident unique to the solar system? Splashing life around a bit doesn't answer that question. We want to find another sample of life, and it could be right here on Earth, as I've already mentioned. It could be a shadow biosphere. Has life happened more than once? Because if it's happened twice, surely it's happened many, many times. So it's either 0, 1, or infinity, in my view. And at the moment, all we can say is 1 is certain, but we don't know just how improbable that is.
That brings me naturally to Darren Dugan's question, which is that could DNA be an alien artifact? After all, it survives billions of years, or at least a long time. And so this would sort of reverse, maybe we didn't splash Venus, but maybe the life on Earth itself got seeded from a rock from some other planet. And are we the aliens, in fact?
I feel strongly about that too, but Sarah, I don't want to keep jumping in.
Yeah, I also feel strongly about this one. I think, you know, a lot of people want to make the claim that maybe life originated elsewhere and came to Earth. And I think that's actually making the problem way too hard, because it's basically pushing back the origin of life problem to an unknown environment, where then we have to try to explain how DNA emerged in the first place. So I think when you're asking things about, like, if DNA is an alien artifact, it might be an intriguing kind of sci-fi story, but it's not a very constructive question to ask scientifically, because there's no real possibility of getting at that question in a tractable way, nor does it help us solve the origin of life problem. But I think there's also this other issue, which people assume that the origin of life process, or how life gets started on a planet, is decoupled from the planetary environment. And so we could have DNA just be thrown on a planet, and it would be able to start replicating, and then take over the planet, and, you know, life would be able to start anew there. And I think that's really like a Darwinian fallacy about the idea of like a selfish gene or a selfish replicator that can just survive in any environment and produce itself. And the truth of the matter is that our metabolism, like all of the energy that fuels the reproduction of life as we know it, is intimately tied to the geochemistry of our planet. And we don't even know, if we take Earth life off Earth, if it will be viable in an alien environment. Even if we take all of our technology and our DNA and other things, it's going to take a lot of engineering and infrastructure to be able to do that. So it's not just about the DNA molecule itself. You need the entire cellular architecture. And in fact, you may even need actual entire ecosystems to be able to move life between planets. And we just wrote a paper on that, actually, that came out in Astrobiology recently, about ecosystems being the right scale for thinking about migration between planets. So it's not just about a molecule. So it's just not explanatory, and it also doesn't help us with some of the questions that we need to answer in a meaningful way. Paul, do you want to add to that?
Yeah. Of course, I agree with everything you've said, and thought a lot about if we wanted to go and colonize another planet that has no life. It's not just enough to send the astronauts and a few pigs and cabbages and so on. We know we have an entire vast microbiome within us, and the planet has a microbiome. We have no idea, in that intricate web of life, what is a self-sustaining subset you could pluck out and transport in isolation. I sort of suspect you need almost the whole thing. And so I agree, it's not just a matter of sending one microbe. We did, the Beyond Center, you will remember, did have an entire workshop on this back in January, in pre-pandemic days, and it was on panspermia, the idea that maybe an alien civilization had sent life to Earth to seed our planet, because it's true that life did get going on Earth pretty quickly after it became suitable. And Francis Crick, no less, suggested many decades ago that maybe it was deliberate directed panspermia. I think we probably felt that this was not the explanation for life. And as you point out, it doesn't help much, because although if you take the entire volume of the universe, you've got more chances of life starting, and you've got a longer period. You've got maybe 12 billion years in which life could evolve. If the odds against forming life are exceedingly small, a factor of 3 or something in the age, in the timescale, doesn't really help very much. So I think you just push the problem off to somewhere else. But I did allude, in passing in my presentation, that what we might detect, let's forget DNA because it really does go right back to the origin of life, but we might detect, supposing we found a shadow biosphere and it was not DNA based, and we could do a sort of phylogenetic tree like we do with DNA, and we would deduce that it originated not 3.5 billion years ago, but 1.5 billion years ago. And then you think, well, how did that start? That looks like a second genesis. Is that an alien? Is that a technosignature? Or it doesn't even have to be a separate tree of life. It could be a really weird side branch on the known tree of life that sort of bursts into existence, a bit like the Cambrian explosion for multicellular organisms. I'm not suggesting that was triggered by the aliens, but something at the microbial level, which is sufficiently distant, sufficiently abrupt and dramatic, with a date that you could pin down that would be relatively recent. Then you might say, aha, what caused that? That's the sort of thing we might look for.
Thank you. I just want to remark, when we're looking at the Drake equation, it's true that all the numbers many of the numbers, especially on the biology side, are unknown. But on the physics side, we now know that there are 100 billion stars in our galaxy and about 100 billion galaxies, and that most of these stars seem to have planets. So that gives us about 10,000 pentillion times to play the games, whatever the odds are. Well, I don't know what that
and Maulik, that was not the case when I was a student and got interested in this. People were saying, well, we don't know there are any other planets outside the solar system.
That's been the real challenge. We now realize that the fact that the sun has planets is not at all special. I want to ask some other questions here that have come from in the chat. There are 2 similar questions, one by Sophie Fairbairn and another by Barbara Temple, who basically ask, how are we supposed to communicate with aliens? What are the chances that alien could even understand us? And if we were to make contact, what method of communication ought we to use? Mathematics, music, or pictures, or what?
I vote for mathematics every time.
I was going to say, we can't hinge bets on mathematics because that might be human-centric too. But that's, yeah.
Well, let me give you an example, Sarah, where I think it would speak volumes in one number. And that is if we send the value of the fine structure constant in binary. Because the fine structure constant, which for those of you out there who are not physicists, is a dimensionless number. It's the square of the charge on the electron divided by Planck's constant over 2 pi and the speed of light, and it's about 1 divided by 137. It's a pure number. It's the same for everybody anywhere in the universe. You wouldn't know about that number unless you knew quantum electrodynamics. That's where it comes from. It comes from that field. You have to look at atomic spectra and so on. So just that one number tells anyone who's out there, not only do we know about mathematics, but we know about quantum electrodynamics. So we've got that far in our development. This is one number. There can't be any ambiguity in it. And if you send it in binary, there's nothing simpler. So there's nothing human-centric, I think, about the fine structure constant.
So
what about pi?
Pi?
Yes.
You could do pi, yes, but pi tells you we know mathematics, doesn't tell you we know physics. Whereas the fine structure constant, you get both.
So I would just make the argument that just like language is something that humans have learned and might be intrinsic to humans, mathematics might be the same. And we have a tendency to think that it's more universal because we can use it to describe phenomena in physics. But it doesn't mean that an alien mind would actually describe the world at all mathematically. They might have invented some other completely different system. And so just like, for example, gender might be a universal concept across human civilizations, it doesn't mean that when I look at like the Rosetta Stone or something, I can pick out the word for boy or girl. I have to actually know the structure of the language and how that civilization was thinking about things and how they encoded it. And perhaps alien technologies don't use mathematics the way that we do. And they've invented completely alternative constructs. Yeah, I know.
You might be right. It's true that we can be very parochial in this game.
Yeah.
Although, of course, people will often remark, well, if they had a totally different way of looking at the world, the chances are they wouldn't develop anything like the type of technology we're familiar with, communication channels and so on. So we probably wouldn't know they're there. So it might be a bit like the Quintelligence having great thoughts in cyberspace, but not really, it doesn't mean anything to us. But I do think in this game, when we're speculating about unknown minds and kinds of minds, to be as broad as possible in our speculation. So expect the unexpected. And in the area of science, I tried to let's even get away from this idea of technology. We think of chunks of metal and straight edges and blinking lights and all that stuff. Trying to just get people to think about, what would be something really, really weird. Might not be something even with a definite size and shape. And there are all sorts of ways you can generalize from our sort of everyday experience, which we have, our cognitive architecture is a product of evolution, and evolution's fashioned us to solve certain problems, and we've got to get away from that and think the unthinkable.
Mm-hmm.
So in the 1970s, there was a famous meeting, I think organized by the Air Force, in which Carl Sagan showed photographs of a planet taken at, I think it was 10-kilometer resolution or something like that. And so there was these quite detailed photographs of this planet, and there was almost no signs of life on this planet from 10 kilometers. But that planet was Earth. And the question is, if aliens were looking at us, and this is a question from Scott Riley, how would they know that there was life on Earth? Do we glow green? Are there biological signatures that they would definitively be able to use to identify life here?
I did mention a couple in my presentation. One is the Great Wall of China, and the other is the pyramids. The human 1970s technology didn't have that capability, but if your civilization has been around for 1 million years, you could have some pretty high resolution stuff, or you might have probes sending back high resolution pictures. But there's also the atmosphere. It changed with the Industrial Revolution, it changed with the Agricultural Revolution, and then it changed with nuclear weapons. So all of these things are techno-signatures. And so you just need some fancy stuff. You need a big budget, basically. If you can spend enough, you could detect intelligent life on Earth, no problem.
I feel like there's a deeper truth there than just looking for aliens. I was just going to add to that, I think I agree with all the points that Paul was making. I also think any of the logic that we talked about today for us looking for aliens, you could probably invert and talk about how challenging it would be for them to detect us. But the way a lot of scientists do it in practice is actually when we're looking for life on exoplanets, we often use Earth as a model, and we devise computational and theoretical models of observing Earth as an exoplanet, and what would our telescopes that we're building right now be able to detect from Earth. And so in that case, they're looking mostly for atmospheric gases like oxygen or methane, or perhaps some technosignature gases, as Paul was alluding to. So So there are ways that we think about doing that as being constructive to look for alien life, but it's obviously not conclusive because it makes a lot of assumptions.
As far as I remember in the 1970s, the only evidence, the Great Wall of China did not show up because it was too thin.
Yeah.
But the only evidence of life on Earth at that resolution was in Canada. There was a sort of rectangular pattern where Canadian loggers had done their logging in a grid shape. So here's a question from Adriana Matthews, who asks, how do you think the general population would react to finding extraterrestrial life?
Well, again, I've thought a lot about that. So I think there's a very good answer to that. It's a little bit like Copernicus and the Earth going around the sun, or Darwin and the theory of evolution. You know, how did society react? And the answer is that I can imagine that for about a week, it would eclipse even the US election as great news. And then people would go back to baseball or cricket or whatever is more important to them. And so it wouldn't have a huge impact in the medium term. But over the longer term, if you say, well, who cares that the Earth goes around the sun, or who cares that humans have evolved from other life forms on this planet doesn't affect the price of beer or anything like that. But the truth is it seeps into our consciousness, into our culture in many, many ways. And so it colors the sort of backdrop of our worldview. And the same would be true, I think, of the discovery that we are not alone. Big news, then it would all go away, and then over a century or so, it will make a difference to the way we see ourselves.
Yeah, I'll just add to that really briefly. Like with the discovery of phosphine on Venus, I think it made a big splash for a day, and then that news disappeared, even though it was a purported claim of alien life. And also, I think part of the reason it will decay so quickly is that most people are already under the assumption that alien life is out there. If you talk to a lot of people and you tell them that we don't know of any examples of aliens, they're quite shocked. So I'm not sure that they would be entirely surprised if we actually made a discovery.
Although I think that if we found life that was clearly more intelligent than us, it would be quite a shock.
Yeah. I think what would be actually more shocking is if we could prove there was no other life out there. That would really shock people. But finding it won't shock them as much in the immediate.
People often say, well, if we knew we were alone, we'd take better care of our planet. But on the other hand, I personally would be very depressed. Although I say, well, I'm pretty skeptical about life out there because we don't know the probability it's going to evolve.
But the hope is.
I really hope that we're not alone. I'd like to think there's a life principle at work in the universe and that we are one instantiation of it.
Me too.
Are we out of time, or do we have time for one last question?
Maulik, I think you're muted.
Yes.
Yes, I am muted. I think we're just about out of time. So I'd like to thank everybody for attending and thank the speakers for their wonderful presentations and insights. And this Ask a Physicist series will continue. Our next meeting will take place on November 30th at 6 p.m. And we'll be discussing how many universes are there, universe or multiverse. Thank you all for coming.
Thank you, everyone. Thanks for the great questions.